Okay, so next is the isolation of the resins. So as you already know about the resins, okay, so they are the mixture of the that is the volatile oils and the oxygenated products of the terpenes, and like they are having the heterogeneous structures, so they are made up of the carbon atoms. Okay, so they are having the complex structures and they are like transparent or translucent in appearance. So when coming to the properties of these resins, you already know. So they are going to melt once you are going to heat, and they are going to produce the smoky flame. So when coming to the solubility, so they are insoluble in water, but they are soluble in the organic solvent. So when coming to the isolation of the curcumin, so this curcumin, so you are going to found in the turmeric, that is the rhizome. So when coming to this turmeric, so in biological source, so it consists of the dried rhizomes of the curcuma longa, so belong to the family Gingiberaceae. So when coming to these curcumins, so they are the diaryl heptanoidal compounds, or they are the resins. So it is going to so main coloring principle, so like it is like made up of the 5% of the rhizome. So apart from that, it is made up of the other constituents like the dexmethoxy curcumin and the bis desmethoxy curcumin. Okay, so when coming to the isolation part, so this curcumin, so we are going to isolate by using the different processes. So first method, the turmeric powder, so we are going to extract with the alcohol by using the chocolate extractor. The alcoholic extract so is concentrated under reduced pressure and dried. In another procedure, the turmeric powder is firstly extracted with the hexane followed by acetone. The acetone extract is concentrated and dried to yield the curcumin. So when coming to the most efficient way for the isolating of the curcumin, so was to found the isolation with the ethanol. Then we are going to concentrate and filter. Then we are going to throw the concentrate on the superior grade kerosene. So when the solid mass separate, the mass is stripped off from the kerosene with the petroleum ether and recrystallized from the ethanol. The final product obtained is recrystallized from the hot ethanol to yield the orange red needles of the curcumin. Okay, so simple. So either you are going to go with the alcohol, or you can go with the organic solvents, so like the by using the ether or the benzene. Okay, so like first you can go with the alcohol method, so by using the chocolate extractor or by using the distillation method. So you are going to get the alcoholic extract. So that alcoholic extract you are going to evaporate and you are going to condense. So you are going to get the that is the dried powder of the curcumins. In another method, so you are going to use the hexane and the acetone. So hexane is going to remove the other impurities, so other than the curcumin, and when coming to the acetone, so it is used to extract the curcumins. And like in another method, so again you are going to go with the extraction with the ethanol, and we are going to filter. So then you are going to take out the ethanolic extract and you are going to throw on the superior grade kerosene. On the kerosene you are going to throw that ethanolic extract. So then it is going to forms the mass on the kerosene layer. So that kerosene layer you are going to take out and you are going to wash with the petroleum ether, and you are going to get the orange red crystals of the curcumin. Okay, so when coming to the identification, so you are going to go with the TLC. So in this for the sample you are going to use 1 ml of the curcumin in 1 ml of the methanol. When coming to the stationary phase, we are going to use the silica gel G. When coming to the solvent system, we are going to use the chloroform ethanol and the glacial acetic acid, so in the ratio of 94:5:1. When coming to the spot visualization, so we are going to go with the detection, we are going to go with the UV at 366 nanometer. Then it is going to develop the bright yellow color fluorescent spot, which is having the RF value of 0.79. When coming to the by using the FTIR, so here you are going to use the isolated curcuminoids. It is mixed with the IR grade, so potassium bromide, so in the ratio of 1:100. Then the mixture which is prepared, that is the pellet. So by applying, so you are going to prepare the pellet, or you are going to prepare the tablet by applying the pressure by using the hydraulic press. So then the pellet, so it is scanned in an inert atmosphere over a wave number of 4000 to 500 centimeter per inner square by using the FTIR instrument. So I am coming to the isolation of the phodophylotoxin. So again it is also a resin. So like when coming to the biological source, it is obtained from the root and rhizome of Phodophyllum hexandrum, belong to the family Barbadeaceae. So when coming to the isolation part, so here we are going to take out the powders of the rhizome or the root, and we are going to extract with the methanol. Then we are going to reduce the volume. So then this semi-solid mass we are going to put in water, that is the acidated water. So means 10 ml of the HCl in 100 ml of that is the water. So then these precipitates are allowed to settle. Then you are going to filter. Then you are going to wash with cold water. So when you are going to obtain the precipitate of the resins, so what the resins you are going to get, you are going to dry. So it is going to give the dark brown amorphous powder called phodophyllin. The obtained powder is extracted with the chloroform, and further purification is done by repeated recrystallization from benzene, so followed by washing with the petroleum ether. So it is going to yield the phodophylotoxin. So when coming to the another method, so in this method you are going to dissolve, you are going to take on the powder, you are going to dissolve with the this chloroform, and you are going to extract by using the alcohol. So then it is refluxed with the neutral ammonium oxide. So this solution become that is the light yellow. So to the alcoholic solution we are going to add the benzene, which is going to yield the 95 to 98% of the phodophylotoxin. So you can go with the another method. So in this method you are going to extract over the neutral alumina, so with the solvent like the benzene, toluene or the xylene, so by using the column chromatography. So again for the recrystallization you are going to use the benzene or the toluene, so to yield the that is the pure phodophylotoxin. Okay, so when coming to the identification, so we can go with the TLC. So in this TLC you are going to use the methanol to dissolve the sample. So when coming to the stationary phase you are going to use the silica gel G. When coming to the solvent you are going to use the toluene ethyl acetate in the ratio of 5:7. So when coming to the detecting agent you are going to use the sulfuric acid. So when coming to the spot you are going to visualize the spot under, so that is the UV light. So it is going to produce the violet color, so which is having the RF value of that is the 0.39. And coming to the identification test, so just the drug you are going to treat with H2SO4, so it is going to give blue color. So another test, that is the alcoholic extract of phodophylotoxin plus 5 ml of 1 normal potassium hydroxide, it is going to give you the stiff jelly mass. So when coming to the estimation, so either you can go with the HPLC or any of the other methods. So we are going to go with the HPLC. So in this we are going to use the detector at 283 that is the nanometer. So when coming to the mobile phase, here we are going to use the methanol and water in the ratio of 6:4. Okay, so when coming to the uses, so like this phodophylotoxin, so it is if you are going to take by mouth, it is poisonous. So but if you are going to use in the treatment of the bowels, and it is going to kill the parasitic worms in the intestine, and it is going to counteract the snake bites, and so for it has been used as laxative.